Hey folks, welcome back to another video. Today we'll be looking at question 754, reach a number. This problem will be using a mathematical solution to solve this problem, and just to be able to understand the solution better, I have the solution coded up already, and we will walk through that and try to run through an example to see why that works. So we'll be initializing two variables on the get-go. The first thing we do is the number of steps. We initialize that to 0, and the sum that we have so far, which is also initialized to 0. And then the loop, what we do is we keep incrementing the sum and increasing the steps till we have the sum to be less than the target. As soon as it's equal to or greater than target, we break, and you check for one last condition before actually returning the steps. The thing you check is that if the difference between the sum and the target is not divisible by 2, if the remainder between the sum and the target is not even, you keep adding the sum with the number of steps that we have to take to make it even. And the reason why we're doing this is because of this. Look at these two examples right here. So let's start with example 4, right? So we have target to be 4, and then we have 1, 2, and 3. We have that to be 6, and this right here is a part that we have completed. So as soon as we reach 6, we know that the difference between 6 and 4 is equal to 2. So we would return this as is. We'll return the number of steps as is, because what we can do is we can change the sign of 1 to negative and then add 2 and then add 3. So what does this become? So this is 2 plus 3, which is 5, minus 1 is equal to 4. The reason why we're doing this is because whatever difference that you have, you need to be able to have half of that number in the summation already. Because you are going back one step, you need something to be able to compensate for the one step that's gone back and also come front. So that's the reason why you try to subtract half, and you cannot do that unless and until the remainder is a even number. And look at this. Look at example where we have target to be equal to 5. You have 1, 2, and 3. You have 6. So at this point, we have completed this while loop. And then when you subtract 6 and 5, you have 1. You do not really have, it doesn't really meet this condition. We continue adding. So we have 6 to be the sum, and then you add 4 to it, which is 10. So 10 minus 5 is still 5, so it doesn't make sense. So you continue adding it. And then you have 10, and you add 5 to that, you have 15. And then 15 minus 5 will become 10. So that remainder right there is even. That time, if you check, if you have 1, 2, 3, 4, and 5, if you switch the sign of 2 and 3, it becomes 5. So the entire premise of the solution is that you need to be able to have the remainder of the target and the sum to be an even number. And the reason why you're doing that is because you have to compensate for the number moving backwards, and it has to come forward. That's the reason why we try to make sure that the remainder can be divided by 2, so that some other number can compensate for the fact that we have moved back and we have to come forward for that. I hope that makes sense. It's a little tricky to understand if you don't draw it out. I highly recommend drawing it out and using a few examples to understand the solution yourself. If you have any questions, please do let me know in the comments below. Let's just quickly analyze the space and time complexity of this entire solution. The space complexity is of 1, because we're not really using any additional data structures to save anything. And time complexity would be O to the power of half, which is n root of n. And the reason why that is because to get to a particular number n, you can use the formula k multiplied by k plus 1 divided by 2. So this is the summation formula. So to get this, you would use root of n to get to the problem. That's the reason why it is time complexity of O of n. So I hope that makes sense. Let me know if you have any questions about this particular problem. If there are any questions that you want me to solve, let me know in the comments below. I would really appreciate that. And please don't forget to like, share, and subscribe. I'll see you all in the next video.